All right. BC, Unit 1, Assignment 1, summary of calculus so far. So here are the answers. Should have checked these already, but some of your answers might vary a bit just because they're using some estimation techniques and stuff and trying to kind of roughly count squares or rise over run. So if probably should have answers close to some of these. Some of these are exact. So you pause it, check them all. Back. Pause it, check them. Okay. So this should be an in, by the way, right here. Okay. Let's try these problems. So number one, estimate the definite integral of f of x. So the definite integral is this. This is an integral. Definite integral is when you put limits on and you should get a number. So from 1 to 7, trying to count these squares right here, right? Now realize that these are 10 on the vertical axis and one right here. So this is actually worth 10 squares. 10, 10, 10. And then, you might kind of say, I don't know, this is like 9 and this is like 8 and maybe this is like 7. This is about half. So maybe about 5. This looks like it's about 9. Maybe this is about 7. So, your numbers could vary a little bit. But if you add all those up, you got 10, 20, 30, 40, 55, 64, 69, 78, 85. So there you go. Should probably have some work like that on your paper. Number 2, estimate the derivative of f of x at x equals 1 by drawing a line tangent to the graph at that point, measuring slope. So you can maybe use something to help you draw a straight line at 1. So tangent line looks like maybe like not like that. So we could draw tangent line. And we try and find some nice values, or I don't know, we could say up, up. That looks like about 25. This is about 12, maybe. That's about 25. So you could say, well, f prime of 1 is approximately up 13 over 1. I had gotten 16. It really just depends on how you draw the tangent line and what you estimate the values to be, but probably somewhere in the neighborhood. Okay, number 3, the equation of that function is this. Confirm on graph and calculate that this equation really produces a graph. But okay, so we're just gonna graph it. So we're gonna put x to the third minus 11x squared plus 34x minus 12. Window, you can use the window there. Let's say -1 to 8, -1 to 40. Graph. Now it says to turn the grid on, so that's let's see. I don't actually remember where that's at. Grid on. Under settings, mode. don't know. Is it under? Okay, second zoom format. You turn grid on, and it graphs a little grid for you. I don't know. It's not graphing the horizontal grids, but anyways, there you go. That looks right. Okay, so yes, appears to be the answer. Okay. Number 4, estimate the derivative of f(x) at x equals 1 by using f(1.01) and f(0.99). Did the answer come out fairly close to the one you got on problem 2? So what we're doing is we're saying that f prime of 1 is approximately f prime of 1.01 minus f of 0.99 over 1.01 minus 0.99. So that's generally how we estimate derivatives from like a table. Now, I'm going to go back and turn this grid off. And I'm going to go to table, and there's some values there from whenever the last time we used this table. And I'm going to put these in 1.01, 1.99. This is the easiest way to calculate those. So then I'm going to say, all right, 12.149201 minus 11.84. Now, I need more than 3 decimals in my work for my final answer to be 3 decimal accurate. So if you highlight the value, it shows you the more accurate value in the bottom. So we'll do that and do that. I should show some work. Okay, so then I'm going to do this. Let's see. 12.149201 minus 11.849199 is 0.30002 over 1.01 minus 0.99, 0.02. So 0.300002 divided by 0.02 is 15.000. 3 decimal accuracy. Round or truncated comes out to. So yeah, it seems close to my answer on problem number 2. I got 13. So 15 seems pretty close. All right. Number 5. Estimate the definite integral of f of x from 1 to 7 using trapezoidal rule with n equals 6 increments. Did the answer come fairly close to the one that you got in problem 1? So we're going to do another estimation, but this is more a little more structured. Instead of trying to count squares, which was kind of rough, we're going to do trapezoids. So we need to, I would draw these in. These are your trapezoids. Okay, we need the values of those. So, I mean, this looks like it's 12. That looks like it's 20. So the area of a trapezoid is the average of the bases times height. The heights of all of these are 1. Okay. The bases are vertical, right? Your trapezoid. So 12 plus 20 divided by 2 times the height. So usually if you're asked to use trapezoidal method, you should be showing calculations for the area of trapezoids to get full credit for your response. Next one, I'd say maybe that's like 18. So 20 plus 18 over 2 plus the next one, it looks like 12. So it's going to be 18 plus 12 over 2. And then 12 plus, that looks like 8. Oh, and we got to do one more over here. 8 plus, again, that looks like 12. And then 12 plus 30. So there's your setup. So 32 over 2 is 16. 38 over 2 is 19. 30 over 2 is 15. 20 over 2 is 10. 20 over 2 is 10. And 42 over 2 is 21. And so I get 35, 40, 50, 60, 70, 81. That's my answer. And I got 85 before, so seems pretty good. 81, 85. Kind of depends on the numbers you kind of estimated for those, but okay. The exact value of the integral in problem 5 happens to be an integer by an appropriate technique. Find out what the integer is. So we're actually going to integrate this function. We have the function, and so we could just integrate it by hand and get the exact answer. So that'd be x to the 4th over 4 minus 11x cubed over 3 plus 34x squared over 2 minus 12x. Don't need the plus c. It's a definite integral. So then we plug 7 in. Now, I guess, whatever. Use your calculator to help you. 7 to the 4th is 2401. 7 cubed times 11 is 3773. 7 squared is 49 times 34 is 8. And then divide. Okay, hold on a second. Okay, yeah. So 17 times 49 is 833. And then 12 times 7 is 84. Now, you still got to plug 1 in. So if you plug 1 in, you get 1/4 minus 11/3 plus 17 minus 12. Then you could just do this on a calculator. It's fine. I got 90 exactly. So that's the exact answer. All right. Number 7, use equation problem 3 to determine the equation of the tangent line. Okay, so you need two things for the equation of tangent line. You need the xy pair. So f of 1 is 1 minus 11 plus 34 minus 12 is negative 10, 24, 12. So your xy pair is 1 comma 12. And then you need your derivative. So the derivative of this is 3x squared minus 22x plus 34. And then evaluate it at 1. And we get 3 minus 22 plus 34 is 12 plus 3 is 15. So that's your slope. So then your equation is y minus 12 equals 15 times x minus 1. Point slope form, leave it. That's it. Okay, if you did slope intercept, you get 15x minus 15 plus 12 is minus 3. Sure, if you want, but just do point slope form. Okay, so yeah, a lot of good stuff on here from last year. Which is false? All squares are quadrilaterals. True. Pi is not a constant. False. Pi is a constant. My point is zero dimensional. True. Horizontal line slope is always 0. True. So, I don't know. Whatever. Okay, number 9. I taught you guys this trick last year, so this is the way I want you to do it. Where we try and change a repeating non-terminating decimal into a fraction. So I don't know if you guys remember that trick. So we set it equal to n, and then we multiply by the number of repeating numbers 10 to the power. So it's 10 to the first, both sides. So we get 0.83 repeating, right? And then we subtract n, the original n, line up the decimals. Now the point of this is that the repeating part should go away. So I could just write the 3 over here and then have that repeating. So 9n equals 0.75 and we divide by 9. And so this is n. So n equals 75 over 900. But here's the deal. We're trying to get some number where it's the same number on the top and same number on the bottom from 36. So can we simplify this? 5 goes in 20 times. So that's 180. And 5 goes into this 15 times. We take another 5 out. That'd be 3 over 36. Hey, look at that. There we go. I mean, we could reduce it to 1/12, but this is what's helpful for us. So the question mark up there is a 3. This is the work to go with it. All right, number 10. If the slope of the altitude of AC, so altitude is like a triangle, the height of a shape is 3 points. I'd graph this. I mean, I feel like that's going to be your quickest way to see what's going on. So 0, 2, 2, 6, 3, 4, 5, 6. So that's this is A, 0, 2. This is B, 2, 6. And then C is some unknown value for the X value. So, I mean, we could just say, okay, here's X, X comma 1, just to draw. And that's point C. Now, this point could be anywhere technically along this line, right? So that can move back and forth. But at least that gives us something to work with. Now it says the slope of the altitude to AC. So that would be this line. The slope of the altitude to AC is 5. So the slope of this line is 5. So then what's the slope? Then what's the value of X? Well, if this is 5, then this is perpendicular to that, and it's negative 1/5. So we could set up a slope calculation. The slope of AC is rise over run, and it should equal negative 1/5. And we get negative 1 over X equals negative 1/5. And you could solve it, or you could be like, oh, X equals 5. So there you go. I mean, if the only other option is like if it was over here, what would it be? The altitude to AC would be this line. It'd be the same setup, I think, no matter where it's at. So there you go. 11, we want to solve this without a calculator, so we're going to try to make the bases same. 2 to the 4th, 2 to the 5th, rules of exponents. So to multiply those, and then set the exponents equal to each other. We're not dividing the base out. We're just setting the exponents equal to each other when the bases are the same. So 24 equals 2x. X equals 12. All right. Number 12, you have a graph. What's the minimum value? Well, you graph this to maybe help you. But the minimum is the absolute min. But you also know what a sine curve looks like, right? This is a sine curve. Sine curve usually looks like this. The amplitude is 4 to negative 4, right? And then you're going to move it up 9 units. So the minimum is going to be this point right here, but you can add 9 to negative 4, right? So the min for this is negative 4, and then you're going to add 9, so you're going to get 5 is the minimum value, the y value. So, or you could do extreme value theorem, but you have no endpoints, so it's a little. This one's just trying to simplify this into a nice answer. Is complex fractions, and fractions, and fractions. So the trick is we want to combine these guys together first. And so that's going to be 5/3. And then we want to combine those together. So this is going to be 2/3 times the reciprocal 3/5. So that's going to be 2/5, right? And so now if I rewrite this, it's 1 plus 2/5. So now I'm going to try and get these guys together. So this is the same as 5/5. So that's 7/5. So we're going to multiply by the reciprocal. And we get 1 plus 5 is 6. All right. 14. I said this needs to be an n. Okay. This is sigma notation, or yeah. This is what we use for like series and things like that, which we're going to be studying this year. But that's something you could have learned in earlier classes. In fact, we did talk about it a little bit at the end of last year as a way of rewriting integrals. But the basic idea is you plug 1 in first. 2 plus, 2 times 1, that's going to be 1. The plus, then you plug 2 in, that's 3. Plus, then you plug, so n equals 1, n equals 2, and then n equals 3 is going to be 5, plus n equals 4 is going to be 7, plus n equals 5 would be the last one. So that's going to be 9. So that's that whole thing right there. And then the minus 3 just happens afterwards. So this is 4 plus 9 is 18, 25. Minus 3 is 22. There we go. This is sort of like a number system kind of thing. Like this means decimal. This means some other number base x. So the idea here is that there are 2 tens, or 2 times 10 to the first, plus 9 ones, which is the same as 9 times 10 to the 0. That's how our number system works, okay? So over here, we're going to do 3 times x to the first plus 5 times x to the 0, right? Now, if I write this, I could say, well, this is 29 equals 3x's plus 5. That's going to be 1. That's going to be 1. And now you can figure out what x is supposed to be. So you subtract 5. Divide by 3. And x is 8. That's a base 8 number system, octal, which we actually use in some math and computer science and stuff. All right, there you go. Just a little review of a bunch of different things, a couple little interesting things in there. All right.